Sir, join ಮಾಡ್ಬೋದಾ? Yeah. Get in. Sign and come. हेलो हाँ इधर के अच्छा वाला हेलो கேக்கலையா கேக்குதா hello sir, am I audible?
Yes, good afternoon, sir. You are audible completely.
Is it better? Like, I don't think we have the issue that we faced yesterday.
Yeah,
Right?
it is now better. Yeah, it is
It's
now better
no?
today.
Okay.
Thank you, sir.
எதுப்பா? I got a complaint that you people are not talking. கேட்கலையா? சரி, நான் இந்த கிளாஸ்ல இருக்க போறேன். I'm going to be here. Okay, try to understand if there is any technical issue. So make the class as interactive as possible. Okay. Yeah. See, this is disturbing. Just have a look here. Right. Let's fill up with this. Yeah. You know how to operate?
Yes, sir.
So so when you want to talk, yeah. Akhil, can you move the stick? Can you come here? Up in here. Sorry, no, it's not that. I think that's the one. Is this better? Camera this. Camera another. Those are online. Can you please switch on your videos?
Sir, I'll do this, sir.
Okay. So just I wanted to introduce the students to you.
Okay, sure, sir.
Sir, are you able to see them?
Yeah, I can
so
see
I
them.
just wanted to, you can just tell your names. So,
Siddesh, sir.
Nitish.
Siddesh, sir. See, Siddesh.
Stesh, okay.
Sir, I'm Raghav.
Raghav.
I'm Amrisha.
Amrisha, okay.
Sir, my name is Ratika.
Ratika.
Sir, I'm Meghna.
Can you tell me
Meghna.
again? Meghna. Okay.
Meghna.
Right.
Akhil, sir.
Akhil, okay.
Sir, can you check if you're able to share your screen?
Yeah, sure, sir.
Perfect. Yeah. So can the screen be tilted to landscape? Because here we are able to see only SSD.
Is it now okay?
6:30 on the max to 6:30. Sir Raghav has a class at 6:30. 6:30, he'll be leaving by 6:25.
6:30.
He has a class at 6:30, but he'll be leaving by 6:25. So wanted to keep you
6:25.
informed. Yeah, yeah.
No,
So
sure.
he'll be-
Sure. So shall I start?
Yeah. Thank you.
So dear students, we have discussed yesterday the discovery of electron, right? Can you hear me?
Sir, I can hear you, sir.
Okay, that's fine. So we have already discussed the mass and the charge of the electron. And then we had to today study the discovery of proton, right? So let me share the screen. So discovery of proton. So we have seen that electron was discovered by J.J. Thomson, but this proton, it was discovered by Goldstein. So the name of scientist was Goldstein. Is a talk of 1866. So now how this proton got discovered? It is the same, the discharge tube experiment, which we have already seen. I have told you that if we are just taking a glass tube, which is having 50 or 60 centimeter length, and when the two electrodes were taken inside this, what William Crookes observed, he observed that some rays are coming from the cathode and they are moving towards the anode, isn't it? But here in the discovery of protons, what was observed, that along with these cathode rays, there are also some rays which are coming in the opposite direction. So that means For example, let's say these were our cathode rays, which were moving from cathode and towards the anode. But there are also some rays which are moving in the opposite direction. So that means some rays are coming from the anode towards the cathode. So let me show it here. For example, this is my anode and this is my cathode. I hope that each of you remember that what is actually cathode and what is anode. So do you remember? I had told that cathode is that electrode
Yes,
on
sir.
which reduction takes place, isn't it? And similarly, anode is that electrode on which oxidation takes place, isn't it, right? So cathode is your
Sir.
negative. Exactly. Anode is your positive pole. So this is connected to the negative terminal of the battery here. So this negative terminal, it is shown by a smaller line, and this bigger line, it represents your positive terminal of the battery. And I hope you remember that this battery, it was not a simple battery, it was just HT battery. That's your high tension battery having a voltage of 10,000, right? And I told that what actually happens here, that the rays were coming from cathode towards the anode, which were known as, so these black dotted lines, they are your cathode rays. They are your cathode rays, right? Which we have studied yesterday. And I told that in these cathode rays, there are actually the positively charged, negatively charged particles, which are your electrons. But along with that, it was also observed that there are some rays which are coming in the opposite direction. So here it was the vacuum pump. You already know we decrease the pressure with this vacuum pump up to 10 raised power minus 4 atmosphere, that's ATM. Now here you can represent these lines which were just coming in the opposite direction. So these lines which I have shown here, blue color lines, they are coming in the opposite direction. That means they are moving from anode towards the cathode, and these rays were known as anode rays. So these are my anode rays. These rays are also known as positive rays because they are actually made up of positively charged particles, which we will see ahead. Similarly, anode rays, they are also known as canal rays. So now why they are known as canal rays? Actually, you have to remember that this cathode, it was your perforated cathode. Do you know what is perforated cathode? Perforated. Perforated means any cathode, any electrode which is having pores inside it. That means small holes are there, right? There are small holes inside
Yes, sir.
this. Exactly. Now what will happen? These anode rays, they will just pass through these holes and they will just strike this glass surface here, isn't it? I will show it here.
Yes,
That
sir.
these, exactly, these anode rays, they will just go through these small channels, or what we call as canals. So that's why they are known as canal rays, because they can pass through these holes and they will strike this. Now here what they have did, Goldstein, he just have coated this glass surface, that is the cathode ray glass tube. It was coated with this zinc sulfide material, that is ZNS, zinc sulfide, right? So I hope you remember that this zinc sulfide, it shows the fluorescence. It is a fluorescent material. I have told that fluorescent material or phosphorescent material, it is that material, whenever any particle strikes it, it glows, isn't it? It produces bright spot. So phosphorescence, it shows phosphorescence or fluorescence. It's a phosphorescent or fluorescent material, zinc sulfide. So when these rays, anode rays, they strike this, it starts glowing. That means there is bright spots are formed here, bright spot. So it is because of these anode rays which are just striking this zinc sulfide material. So these rays were known as anode rays, or they are also known as canal rays. Because why they are known as canal rays? Because they can easily pass through these canals, through these holes, through these channels, right? So this is the difference between the cathode ray tube experiment, that is the discovery of electron, and the discovery of proton. So here the cathode was taken as perforated. So that is why we can observe now that along with these cathode rays which were moving from cathode towards the anode, but there are also some rays which are moving from anode towards the cathode. So that means they move in the opposite direction. So these were known as anode rays or positive rays, or you can also call them as canal rays. Now, what were the properties of these canal rays? Let's see on the next page. So let's see the properties of anode rays. So first property, that is same which we have studied in case of cathode rays, that cathode rays, they travel in a straight path. You will remember that these anode rays, they also travel in a straight path. So can you tell me that how we can know that they travel in a straight path? I had told it yesterday.
They kept an object in the path of the rays.
Exactly.
Exactly.
Exactly. Whenever we place a solid object in these rays, there is formation of shadow behind that solid object. So shadow indicates clearly that they travel in a straight path. Okay, so you will remember that these anode rays also travel in a straight path, right? Also travel in a straight path. So they travel in a straight path. Okay, we have already seen it. How to observe this? So we can place a solid object, and then if shadow is formed behind that, so that clearly indicates they travel in a straight path. Now, also the next property of cathode rays, what was that? That was cathode rays are made up of material particles. So here you will also remember that these anode rays, they are also made up of material particles. So I will write it here, that anode rays are also made up of material particles. So how to know this? I have told it yesterday, right?
Keep a light paddle wheel and start rotating.
Exactly. Whenever we have a light paddle wheel and we place it in these anode rays, it will start rotating. So this rotation clearly indicates that they are your material. They are made up of material particles. That means such particles which will have some mass, right? So now, next very important property was that when we just give the electric field to these anode rays, for example, let's say these are my anode rays which are coming from anode towards the cathode. That means they are coming in the opposite direction, right? For example, let's say here it is your here anode, and they are now moving towards the cathode. Now, if we just give the electric field, how to give the electric field? Simply, we can just place here the two metal plates. For example, one of the metal plate, let's say it is connected to the positive terminal of the battery. Another is connected to the negative terminal of the battery. So that means we are just giving the electric field. Now, when we just give this electric field, what was observed? That these anode rays, they just get deflected, they bend towards which? They bend towards this cathode, towards the negative plate. Have you got it?
Yes, sir.
Yes, they are not going straight, they are just getting deflected towards the negative plate. What it indicates?
That made up of positively charged particles.
Exactly. That means these anode rays, they are made up of such particles which have actually positive charge. So I will show it here, that these anode rays, they are made up of positively charged particles. Now, what we call these positively charged particles?
Protons.
We will not call them yet as protons, they are just your cations. So that means they are positively charged ions, they are your cations. I will tell you when we call them as proton. So they are just the cations. So first of all, you will write here the property, that is these anode rays, they get deflected towards anode rays, get deflected towards, they get deflected towards negative plate in electric field. So that means they are made up of, which clearly indicates they are made up of positively charged particles, which are your cations. Now, a very important point to be noted down here is that if we are just having hydrogen gas, then its cation is known as proton. For example, okay, I will just explain it like this. Can you tell me the atomic number of hydrogen? That's 1, right?
Yes.
How many electrons are there in the hydrogen and how many protons?
1 electron, 0 protons.
There is 1 electron and 1 proton.
1
Because
proton.
number of electron, it is always equal to the number of protons until our atom is neutral. If we are having a neutral atom, so number of proton and electron, it will be same. Now, how many neutrons are there? There is 0 neutron. There isn't any neutron, because what is the mass of hydrogen? It is 1, right? So can you tell me how to calculate number of neutrons? Number of neutrons, it's always equal to A minus Z. We will study it in detail ahead. A is your mass number, Z is your atomic number. So mass number is 1 and the atomic number is also 1. So that is your 0. 1 minus 1, that is 0. So that means it has 0 neutron. It doesn't has any neutron in it, right? Yes. Now tell me that when you just pass this hydrogen gas, when you have this hydrogen gas inside the discharge tube, what will happen? First of all, when you are just giving this very high voltage, that means 10,000 volt you are giving, what will happen to the gas? It will first of all, it will dissociate into hydrogen atoms. You will first get the hydrogen atoms. H2 molecule, it will just break. We will get the hydrogen atoms. Then after that, what will happen? This hydrogen atom, it will just lose 1 electron. When it will lose this electron, it will become H positive. That is your positively charged particle. And this H positive, it is known as proton. This H positive, it is known as proton. Got it now why it is known as proton? Stesh, can you tell me?
Yes, sir.
Why it is known as H positive? I told that H positive, it is known as proton. Can you tell me why it is known as proton?
Sir, because the charge was opposite to the electric charge and there's no charge present in the 0 neutrons, so it was called as passive protons.
Yes, see, actually, there was 1 electron, 1 proton, and there was 0 neutron. So, but it is now H positive. That means it has lost 1 electron. So there is now only left proton. So there is now only 1 proton inside it. So that's why it's your proton. So from now onwards, you will remember that H positive is known as proton. So this is very important, that H positive, it is known as proton. But if you are now having helium gas or any other gas, at that time you cannot call it as proton. You will just call it as cation. Okay, I will tell you why. So let's see on the next page. For example, if yes,
sir, so hydrogen has the the tendency to lose electrons, gain electrons as well, sir. So when it
exactly.
does that time also will it be called as a proton or just a cation?
No. See, I will tell you. For example, if hydrogen gains 1 electron, then it will become H negative. At that time, you cannot call it as proton. At that time, you will just call it as it is your anion, negatively charged
Anion.
particle. Yes,
So
exactly.
it cannot be called as an electron as well.
No, you can. There is special name for this H negative. That is it is known as hydride ion. It has a special name, hydride ion. So just you will remember that as H positive is known as proton, H negative is known as hydride ion. So this is very important. It is your anion. It is not you cannot call it as electron because there are 2 electrons inside it now. See,
okay, sir.
Hydrogen, its atomic number is 1, so it has 1 electron, but it has now gained 1 more electron. So that means in H negative, there are 2 electrons. Got it?
Okay, sir.
Yes, exactly. It is known as hydride. Now tell me that if we are now just taking the helium gas. Let me take as helium gas. Helium is your He symbol, atomic number 2. So mass number is 4. So can you tell me how many electrons are there? 2 electrons. Because atomic number is equal to the number of protons. So that means it has 2 protons. Similarly, the proton number, it is always equal to the electron when it is neutral. So number of proton, it is equal to the number of electron when it is neutral. Got it? Is my voice audible?
Yes, sir.
Okay, so I was just saying that in case of helium gas, I'm having here 2 electrons, similarly the 2 protons. Now tell me, when this helium, it will now ionize, when I'm just giving the 10,000 voltage I'm passing here. So can you tell me that here, when we pass 10,000 voltage, it will now ionize. So it will just give you He positive and 1 electron will get removed from this. So 1 electron is lost by this helium. Now tell me, it was having 2 electrons, 2 protons, and similarly it has 2 neutrons in it, because you can calculate number of neutrons by the formula A minus Z. I had told it A is the mass number, that is 4 here. Z is the atomic number, that is 2 here. So 4 minus 2, that is 2. It has 2 neutrons. Now here, tell me that it was having 2 electron, 2 proton, and 2 neutrons. But now 1 electron is lost, so it has only now 1 electron in it. It has now 2 protons in it, and it has now 2 neutrons in it. So that is why you cannot call this He positive as your proton, because it has 2 protons. It has 1 electron in it. It has 2 neutrons in it. So that is why we just call it as cation. So is it now clear?
Yes, sir.
Yes, this is very important concept, that you can call proton only when we are just taking the hydrogen gas. But when you are taking the helium gas, when you are taking the oxygen gas, any other gas, at that time, the positively charged ion formed, that is your cation, you cannot call it as electron, because there are you cannot call it as proton, because there are many protons, there are neutrons also inside it, there are electrons. But in case of hydrogen, it was different, right? In case of hydrogen, it was only proton there, neutron wasn't there. Similarly, electron was only one, which it has already left there, right? Is it now clear?
Yes,
Is
sir.
it okay? Any doubt?
No, sir.
Yes, so you will remember that when you are just using this hydrogen gas, at that time, you get such a positively charged particle, which is your H positive, and this H positive, it is known as proton. So you can only call this as your proton because it has only proton inside it. But for other gases like helium, you can call it as cation, not the proton. So now let's see another property, that is the charge upon mass ratio. So let me write here. Next property you will remember, you will write here that E upon m ratio. I hope you remember what is E upon m ratio, right? That is the charge upon mass ratio, right? E upon m ratio depends on nature of gas. So I hope that you remember in case of cathode rays, E upon m ratio, it was same. Whether you are taking hydrogen gas, helium gas, or any other gas, it was same. But here it is not same. Here it is not same. In case of anode rays, E upon m ratio, it depends on nature of gas. That means it is different for different gases. Have you got it? So can you tell me why it is different for different gases?
Because of the mass of different gases, some gases may be inert, so the
Exactly.
ratio also changes.
Exactly. In case of, see, I will tell you it in detail. For example, let's say we were having hydrogen gas, right? At that time, the cation which we have got here, it was your H positive, right? Now, in case of helium gas, the cation which we have got here, that is your He positive. Similarly, in case of oxygen gas, let's say the cation you are having here, that is your O positive. In case of nitrogen gas, you are getting the positively charged particle, that is your N positive, right? Isn't it?
Yes,
That
sir.
means you are getting different positively charged particles. And that means these are your actually the anode rays which are containing these. And now they will definitely have different E upon M ratio. For example, what is the mass of hydrogen? It is 1, right? It is mass
One.
number that, yeah, exactly. Mass number that is 1. And similarly, in case of helium mass number, it is 4, right? In case of oxygen mass is 16. In case of nitrogen, it is your 14. So different,
14.
they have different mass. So that's why E upon M ratio, it will come out to be different. But now, can you tell me that why the E upon M ratio, it was same in case of cathode rays? Can anybody tell me that why E upon M ratio, it was same in case of cathode rays? Why it was not depending on the nature of gas in case of cathode rays? Can you tell me?
So because the protons does not change, but the electron number does.
See, actually, what were the, tell me first of all that these cathode rays, what they actually contain? Cathode rays, they contain the electrons in it, isn't it? Is it right?
Yes, sir.
Exactly. We have studied yesterday the discovery of electron. I have told you that these cathode rays, they are made up of negatively charged particles, which are known as electrons. So electrons are same here. All in all, so you can just check it out here. For example, when you are taking the hydrogen gas, see, this is the electron, isn't here? I have shown it by this red circle. So when I'm taking the helium gas, same electron is produced. And when I'm taking the oxygen gas, same electron is produced. So in all the different gases, we get the same electrons. But the positively charged particle, that is not same. Here it is H positive, here it is He positive, here it is O positive. So that is why cathode rays, all these cathode rays, they contain the electrons in it. And these electrons will have same E upon M ratio. So that's why it doesn't depend on the nature of gas. But in case of anode rays, we are having different types of positively charged particles. For example, if I'm just taking the hydrogen gas, then it will be H positive. If I'm just taking the helium gas, then it will be your He positive. So I'm having here the different cations. So that is why E upon M ratio, it will not be same. Got it now? This is a very important concept. I hope you have got it. Any doubt here?
No, sir.
No, sir.
Is it clear to all of you?
Yes, sir.
Okay. So then let's move ahead. So this is now E upon M ratio. Now you will remember for hydrogen gas, if we are just taking the hydrogen gas, what is the E upon M ratio? What is the charge and the mass, right? So for hydrogen gas, I told that the positively charged particle which is obtained in case of hydrogen gas, that is your H positive. And I told that this H positive, it is your proton. It is the smallest positively charged particle. Now it is having, you will just remember, it is mass and the charge, which has been experimentally found here. So one is the mass of proton. It was found to be
1.666723 into 10 to the power
okay, into
10
10
to
to
the
the
power
power
23.
10 to the power what?
Minus 20.
27 kg, right? It is the mass of proton. Now, similarly, what is the charge of proton? It was found to be same, but with a positive sign, that is 1.602 into 10 to the power minus 19 coulomb, right? It is the same charge as that of electron, but the difference is only that it is your positively, it is having positive sign, and in case of electron, it was having negative sign. Clear? Is it clear?
Yes, sir.
But
Yes, sir.
sometimes, yes, tell me. Sometimes
Yes, sir.
mass of proton is asked in grams. So can you convert it in grams? Can you convert it into grams?
So 1.6723 into 10 to the power minus 30 grams. Wait, 30 grams.
See, it is your 10 to the power minus 27 kg, right?
24.
Now you have to
24.
convert it into grams. You know that 1 kg is how much? 1 kg is 1000 gram, right?
1000 grams.
So how you can write 1000? You can write it in scientific number 10 to the power 3 gram, right? 10 to the power 3, that is your 1000. So you can just write it here like this, 10 to the power minus 27 into, now it is kg, it is to be converted into grams. So I will multiply it by 10 to the power 3 gram. So it is now converted into grams. Now tell me, when bases are same, power should be added, right? So it is 10 to the power minus 27 and exactly it will be minus 24 gram. So is it now clear? Is it now okay? Have you got all?
Yes, sir.
Yes, this is very important here. So this is the mass of proton and its charge. So you will remember that the charge of this proton, it is same as that of electron. The difference is only that it is positive sign. It is positively charged because proton is positively charged particle, right? So any doubt
Yes.
here?
No, sir.
Okay, so can you now define what is a proton? Can we define what is a proton? Just as we have defined what is electron, similarly, we can define what is proton. So proton is your, it is, I will just write it here, that it is that subatomic particle. It is that subatomic particle. It is that subatomic particle which has mass of, so how much it is having mass? 1.6723 into 10 to the power minus 27 kg and has 1 unit positive charge, right? 1 unit positive charge. So how much is that? That's actually your plus 1.602 into 10 to the power minus 19 coulomb, right? Got it?
Yes, sir.
Yes, sir.
Yeah, exactly. So this is how proton got discovered. So it got discovered simply by the same experiment which was just carried out by the William Crookes, but here Goldstein, he just took the perforated cathode. Perforated means which has small pores or holes inside it, and due to this, these anode rays which were coming from the anode and moving towards the cathode, so they move in the opposite direction, and they struck the glass surface which was coated with zinc sulfide screen, so it started glowing. That means bright spots are formed here, which clearly indicates that anode rays are coming in the opposite direction as that of cathode rays. And when the property was studied, it was found that these anode rays, they just deflected towards the negative plate, which clearly indicates that they are made up of positively charged particles. And when we take the hydrogen lightest known gas, we get H positive as positively charged particle, which is known as proton. And if we take other gases, they have more than one proton inside them, and they have also neutrons and electrons. They are simply known as cations, but only for hydrogen H positive, you will call it as proton. This is very important. Got it? Now you have to remember these two things here. One is the mass of electron. I hope you will remember it. It's 1.6723, or some books write it as 1.674, rounding off. Okay, you will just remember up to 2 digits, that's 1.67. Then the charge of electron, you will remember it is same as that of your electron, but the difference lies here that it is having positive sign. Got it now?
Yes, sir.
Now there is question that, can you tell me what is the origin of anode rays? Where these anode rays they get originated? What is the source? This question is asked. I have told you that cathode rays they get originated from the cathode, right?
Sir,
Yes, sir.
they originate between the space where space between electrons and cathode and anode.
Exactly. Now, can you tell me why they do not originate from the anode? It is the question that why they do not originate from the anode. So originate between the space of anode and cathode. So they get originated between the anode and cathode, right?
Yes, sir.
Now, why they do not get originated from the anode? So you will remember that these anode rays, they do not originate from the anode. But can you tell me why? They do not originate from anode. So can you tell me why it is so?
Sir, unlike electrons, protons, anode rays cannot be they're not loose rays, so they cannot be let out from a particular electrode. So that might be the reason.
Okay, I will tell you. See, I have already told you that how these anode rays they are actually formed. They are formed from the gas which is present there. Okay, I will show it again here. That, for example, if we are just taking the hydrogen gas, isn't it? Hydrogen gas I'm having. So hydrogen gas, it actually gets first dissociated into hydrogen atoms, two hydrogen atoms here, and then these hydrogen atoms they lose one of the electron, and then it gets converted to H positive, right? Isn't it?
Yes, sir.
So this is your proton. This is your proton. So where from this proton came? What is the origin? So it came from the gas. So that means here, if you are having this as your discharge tube, this is your anode here. So anode cannot produce this H positive. It is actually coming from the gas, which is gas is where? Gas is actually the bit in between these anode and cathode. So that is why their origin is in between anode and cathode. So have you got it now? This is very important. Anode and cathode. So that means you will remember that these anode rays, they are actually originating from the gas, which is inside this discharge tube. They are not originating from this anode at all. But in case of cathode, we are just what we are doing. We are just passing the electricity, isn't it here? We are just passing the electricity. What is electric current? Can you tell me what is electric current? It's the flow of charge. It's the flow of electrons. So electrons are just coming from this, and they are also coming from this cathode. So that is why we say that cathode rays, they originate from the cathode, but anode rays do not originate from the anode. They just originate from the gas, which is in between anode and cathode. That is the space lying between anode and cathode. Is it now clear?
Yes, sir.
Exactly. So then let's move ahead. Now we have remembered the actual mass and the actual charge of these protons. Now, can you tell me their relative charge and the relative mass? So I'm again writing here. What is the actual mass of proton? Actual mass of proton. Okay, tell me
1.6.
that whatever I write, are you writing it on your notebook?
Yes, sir.
Okay, anything which gets skipped, you can let me know at that time. Still, I'm just saving these. I can share these later after the class. So actual mass of proton, it is how much? 1.67, right?
1.676 into 10 to the power minus 27 kg.
Okay. Okay, let's take two digits. 1.67 into 10 to the power
Minus 27.
minus 27 kg, right?
Yes, sir.
But can you tell me the average mass, or what we call it as a relative mass? Relative mass of proton. Relative mass of proton. So this much mass, it is taken as 1 unit mass. So I just write it as 1 unit. So just as you just what you say that 1 dozen. How much is 1 dozen?
12 bananas.
Exactly. 1 dozen of anything, it is your 12. Whatever it will be. For example, if I'm just saying 1 dozen oranges, so that means 12 oranges. So similarly, 1 unit mass of proton, it means this much mass, that is 1.67 into 10 to the power minus 27 kg. Okay, then tell me, what is the actual charge of proton? Actual charge.
So positive 1.602 into 10 to the power minus 19 coulomb.
Exactly. So what we can write it, if I'm just writing the relative charge, it is 1.602 into 10 to the power minus 19 coulomb. So if I'm just writing the average charge or the relative charge, so this
Positive 1
much,
coulomb.
yeah, it is, yes, it is just plus 1. It has 1 unit positive charge. So this much is taken as 1 unit. U stands for unified or unit, right? Unified mass. So here it is the unit charge, 1 unit charge. Got it? So this is the relative and the actual. So whenever you have to write the actual, you will write the actual value. And whenever we write the relative, then you can use this plus 1. Similarly, relative mass of proton is taken as 1 unit. Got it?
Sir, shouldn't we write 1 unit coulomb or just 1 unit is enough?
1 unit, it is not the actual unit. See, I hope you have gone through some basic concepts of chemistry, mole concept. What we write there, for example, if you have to write the mass of hydrogen, you just write it as 1 unit, unified mass, right? 1 U.
Yes, sir.
Exactly. Or you can write it as 1 AMU, that is the atomic mass unit, but it is not the actual unit. Actual unit is gram. You just
Grams.
write what is the mass. Yeah, for example, you write the mass of carbon as 12 gram per mole. So this is the
Grams.
actual unit. Gram per mole, it is the molar mass, right? This is the molar mass. So molar mass is the actual mass. This is the relative mass. Whenever I write the U, it is the relative mass. So whenever I write the AMU, it is the relative. It is not the actual. Actual is this molar mass. Got it now?
Yes, sir.
This is very important. I hope you will remember it. So similarly, when I'm just talking that the relative charge of proton, so it is 1 U. You cannot write here the coulomb. Coulomb is the actual unit that is here. 1.602 into 10 to the power minus 19 coulomb. Got it? Yes. So this is very important. Now let's move ahead. And after this, we have to see the discovery of X-rays, actually the radioactivity and X-rays. Then we will study the discovery of neutron. Actually, neutron got discovered later on in 1932 by Chadwick, that we will study later on. First, we have to see the discovery of radioactivity. So have you written down this? Shall I move to the next page?
Yes, sir.
Okay. So I will write here the discovery of, have you discovery of radioactivity? Have you heard this name radioactivity? Radioactivity.
Yes, sir.
What is this radioactivity? Have you heard this name before?
Sir, radioactivity means the frequency of particular light rays is more than the frequency of the red wave. It is called as radio waves. So the movement of
Okay.
these radio waves are called as radioactivity.
No, it is not relevant. Anybody else? Raghu, Akhil, can you tell me?
So radioactivity means like an object emits like radio waves or radioactive particles.
Exactly, a little bit it's correct that radioactivity is a phenomena in which some radiations are emitted by radioactive elements like alpha rays, like beta rays, like the gamma rays. That is actually the radioactivity. Okay, I will write it here. So radioactivity, it is a spontaneous process. So you will write it is the spontaneous emission of various radiations. What type of radiations? For example, like I will write here like alpha rays, right? Similarly, beta rays, gamma rays, etc. And which emits these emission of various radiations from a radioactive element, a radioactive substance, a radioactive element. So what are these radioactive elements? Which element is actually radioactive? This is very important, which you have to remember here. That radioactive element is actually that whose nucleus is unstable. So radioactive element is that whose it has unstable nucleus. So radioactive element has unstable nucleus. That means its nucleus is not stable. So that is why it is emitting various radiations. Unstable nucleus being heavy. Why it is unstable? It is because it is heavy actually. So all the heavier elements, they are your radioactive elements. For example, if I'm just talking of uranium, do you know uranium? It's one of the element having atomic number 92, right?
Yes, sir.
And all those elements which are after uranium, they are all radioactive elements. So elements after uranium, that means having atomic number 92, after that up to atomic number 118, all these elements are radioactive. So elements after uranium are all radioactive. So they are all radioactive because they have heavy nucleus, they are very much heavy, and their nucleus is unstable. Because of this, they actually emit various radiations like alpha rays, like beta rays, like gamma rays. So this is your radioactivity. This phenomena is known as radioactivity, and such elements are known as radioactive elements. Correct? This is very important here. So they are known as radioactive elements. Now, what type of radiations are here emitted by these elements? Beta rays, like similarly alpha rays and gamma rays. And how it was actually observed, this radioactivity, it was discovered by Henry Becquerel. The name of the scientist was Henry Becquerel. Henry Becquerel, it's discovered this radioactivity. Now let's see how he actually discovered this radioactivity. So have you got this spontaneous here? The term spontaneous. Spontaneous means continuous emission, right? So that means it doesn't stop. It is the continuous process. That means these alpha, beta, and gamma rays, they are continuously emitted by these radioactive elements. So this is a spontaneous process. So have you written down this? Shall I move to the next page?
Yes, sir.
Okay. So see actually what he did. Henry Becquerel, he just take uranium or radium. We are having various elements. Uranium, we are having radium, we are having they are your plutonium we are having, they are radioactive elements. So you can take any one of these, and he just placed this uranium in this cavity of lead. It is a block of lead here. You can just show it like this. So this is my block of lead. Do you know what is the symbol of lead?
PB.
Exactly. Why? Because its later name is, can you tell me why its symbol is PB? What is the later name of lead? Its later name is palumbum, right? Palumbum. That's why its symbol is PB. Got it?
Yes, sir.
Yeah, exactly. Now see, from this uranium, the various radiations will be emitted here. Because I told that it is a radioactive substance, so it will just emit various radiations. So now, when this electric field was actually given, 3 types of radiations were here observed by Henry Becquerel. So here it was given the electric field. So how to give the electric field? I have already told you that we just take the 2 metal plates. One is connected to the positive terminal of the battery, and another is connected to the negative terminal of the battery. Let's say this is my negative plate here that is connected to the negative terminal of the battery. So there will be now electric field. Now what he observed that here some rays, they just pass it straight without any deflection, right? Some rays, they pass it without any deflection here. They pass it straight, and they are your gamma rays. So you will remember that these are your gamma rays which pass it straight. You can write with this symbol gamma, or you can write as like this GAMMA, gamma rays. So now tell me, he observed also that some rays, they just got deflected towards this positive plate. Some rays, they got deflected towards this positive plate. And what were these rays? They were your beta rays. Got it? Beta rays. So similarly, he also observed that some rays, they are just getting deflected towards this negative plate, negative pole, and these were known as, they were your alpha rays. Alpha rays. So we're having 3 types of radiations here, which are just coming from this radioactive element, that's your uranium. So have you got it? That uranium is your radioactive element, and it emits 3 types of radiations: alpha rays, similarly beta rays, and gamma rays. So alpha rays are those which actually got deflected towards the negative plate, and similarly beta rays, they got deflected towards the positive plate, and gamma rays, they didn't got deflected. They just pass it straight without any deflection. Got it? Have you written down this?
Yes, sir.
Okay.
Yes,
Now
sir.
let's see one by one what are actually these. So first of all, we are just having the first type, that's your, let's take alpha rays. So can you tell me that these alpha rays, they will be made up of which particles? They are actually made up of particles known as alpha particles, right? So alpha rays, they contain alpha particles in them, isn't it? Alpha rays, they contain alpha particles in them. Now, what are these alpha particles? So first of all, can you tell me, for example, okay, tell me, Akhil, that will these alpha particles be positively charged or negatively charged or neutral?
So positive.
Exactly, they will be positively charged because they are actually getting deflected towards the negative plate. So that means they are positively charged. Okay, so I will write here that these alpha particles, they are positively charged particles, positively charged particles having 2 unit of mass and 2 unit of charge, having 2 units of charge and 4 units of mass. So this is the definition of alpha particle. They have 2 units of charge and 4 units of mass. Is it now clear? So that means these alpha particles, they are positively charged. So how much positive charge they are having? They are having 2 units of positive charge, and they are having how much mass? They are having 4 units of mass. So these are known as alpha particles. Now, what is actually this alpha particle? Which particle has actually 2 unit charge and 4 unit mass? So can you guess? Can you tell me which element is having mass 4?
Sir, helium.
Helium.
Exactly, it is the helium. So, okay, let me write on the next page. Have you written down this? Have you written down? Shall I move to the next page?
Sir, 1 minute, sir.
Okay, sure.
Sir, you can continue.
Okay, sure. Now see here that is my voice audible?
Sir.
Okay, so I was just saying that alpha particle, which is actually that. So you will remember that alpha particle, it is just like this. I told that it is having mass 4. So that means it is definitely your helium. Helium is having mass 4, and helium, its atomic number is 2. But tell me, helium, how many protons are there? 2 protons, right? How many electrons are there? There are 2 electrons. So what is the, okay, neutrons are there too. So that neutron is neutral, so it doesn't have any charge on it. Neutron is neutral, so it will not matter here. But proton is positively charged and electron is negatively charged. Both are your charged particles. So that means it has total of 4 unit charge, but we have told that alpha particle, it has only 2 units of charge. So that means you have to first remove the 2 electrons from this helium. So what it will become? It will become, when you just remove 2 electrons from this helium, it will now become He2 positive. Is it correct? Because I have just removed the 2 electrons from this helium. So what it will become? It will become He2 positive. Correct? Have you got it?
Yes, sir.
And this He2 positive, it is known as alpha particle. Clear? This is known as alpha particle. So because it has now 2 units of charge, because there are now only 2 protons in it, so that is, it has positive charge. So that is why I told that alpha particles, they are positively charged. So that is why they got deflected towards the negative plate. Is it now clear? So if I'm just saying that I'm having alpha rays, so these alpha rays, they what actually contain? They contain alpha particles. And what are alpha particles? They are actually your He2 positive particles. So these are your alpha particles. So that is why they are positively charged and they got deflected towards the negative plate. And that's why I told that these alpha particles, they have 2 units of positive charge, isn't it? They have 2 units of positive charge, correct? 2 units of positive charge. And I also told that they have 4 units of mass, because helium is having 4 unit mass, right? Is it clear? Have you got it now? So is it clear? What is alpha particle? Can you define it now?
positively charged particle which has 2 units of positive charge and 4 units of mass.
Exactly. Now there is also another way to define this alpha particle. That is actually, we can also say that this alpha particle, it is your positively charged helium nucleus, correct? Okay, I will write it
Sir.
here that it is your, yes, tell me.
Sir, sir, at 6:30 I have another class, sir. So can I leave now?
Yes, sir, I will just complete it within a minute. So
Okay, sir.
I have already been told that it is to be closed at 6:25, right?
Yes, sir.
Okay, so it is a positively charged helium nucleus. So this is known as positively charged helium nucleus is known as alpha particle. So this is another way to define alpha particle, positively charged helium nucleus. Got it? Positively charged helium nucleus. Is it now
Sir,
fine?
one doubt again.
Yes, tell me.
The nucleus will also have neutrons in it. So how can we tell that the nucleus is positive and novel, sir?
It is very simple. Okay, I will tell you. See, when I'm just saying that I'm having helium. So tell me how many protons are there? 2 protons. How many electrons are there? There are 2
2
electrons. And similarly, there are 2 neutrons. Now, can you tell
Neutron.
me where are these neutrons and protons? Neutrons and protons, they are present in the nucleus, right? We will see ahead
Yes,
in
sir.
the model. Yes, 2 protons and 2 neutrons, they are in the nucleus. And where are the electrons?
Orbiting them.
Exactly. Electrons are outside the nucleus and they are just in the orbitals. Okay, they are just revolving around the nucleus. So now I told that you have to just remove the 2 electrons from this. So if I will just take 2 electrons out of this, what is left there? There is left the nucleus. So nucleus is having 2 protons and it has 2 neutrons. Neutron is neutral, it doesn't has any charge. So what is the charge left there? Charge is because of proton. So that is why I told that it is positively charged helium nucleus. Is it now clear? Is it now okay? Have you got
Yes,
it?
sir. Yes, sir.
Exactly. So that is why we say that alpha particle, it is your helium nucleus. So Raghu, you can just now leave if you are having another class. Are you
Sir, yes,
all
sir.
having other class?
No, sir, only me.
No, sir.
Okay, okay. So you can leave then.
Okay, sir. Thank you, sir.
Most welcome. So have you got what is alpha particle?
Yes, sir.
Yes, can you hear me, Stesh, Magna, Akhil,
Yes, sir. I
Amrish,
can.
Pratika? Can you hear me all? Now tell me that, have you got any question here? Anybody having any question, any doubt?
No, sir.
Anybody else?
No questions, sir.
Okay, so tell me, shall we continue or shall we stop today's class here?
They can continue, sir.
Okay, sure. So I told that what is actually alpha particle. Then let's move ahead. So alpha rays, they contain your alpha particle, that is your positively charged particle, and it has 2 units of charge and 4 units of mass, right? Okay, so let me
Yes, sir.
share again. Now let's see what are then the beta rays, right? What are the beta rays? So as I told that alpha rays, they contain alpha particle in them, and similarly beta rays, they contain the beta particles, right? Now, what are these beta particles? They are just similar to that, similar to electrons, similar to electrons. So what are electrons? They are negatively charged, isn't it? Are electrons negatively charged? Right. So I will write that they are negatively charged particles having SAM E upon M ratio. You know what E upon M ratio? Charge upon mass
Yes,
ratio,
sir.
right? Yes, as that of electrons. So that is why I am just saying that they are similar to electrons, because they are having SAM E upon M ratio as that of electrons, right? So this is what are beta particles. So beta particles, they are your negatively charged particles having SAM E upon M ratio as that of electrons. So you will remember that sometimes it's defined like this, that beta particles, they are just your fast moving electrons, fast moving electrons. So whenever anybody will ask you what are beta particles, you will just say that they are your negatively charged particles having SAM E upon M ratio as that of electrons. Got it now?
Sir,
Yes, sir.
no doubt.
Yes, yes. Okay, tell me.
So if beta particles are similar to electrons, then are beta rays similar to cathode rays?
Beta rays are similar to cathode rays. Now, see, there is a very little bit difference. Yeah, you can say that cathode rays, they are your just electrons, and beta particles are also your electrons. But here, these beta rays, they are just fast moving electrons. For example, if you will just say you are having electron, right? So electron, it is your negatively charged particle, and it has E upon M ratio, which I already told you that 1.67 into 10 raised to power 11 coulomb per kg. But here beta particles, they are just fast moving electrons, and they are just emitted from the nucleus. So we can say that they are just similar to the electrons, but you cannot say exactly they are electrons. So this is the difference. I hope you have got it. Have you got it?
Okay, sir. Okay, sir. Get it.
Yes, I will again repeat it, that I'm just saying that these beta particles, they are similar to electrons, but you cannot say that they are electrons. They are just electron. No. Why? Because they are just emitted from the particular element, from the nucleus of the element, because nucleus is unstable. They are just emitted from the nucleus. So that's why there is special name given to them, that is the beta rays. Is it now clear?
Okay, sir.
Okay, then let's see what is the next, that is the gamma rays. So gamma rays are your electromagnetic radiations. That means they are neutral. They do not have any charge. Electromagnetic radiations. Gamma rays are electromagnetic radiations. Electromagnetic radiations which are neutral, right? Because any electromagnetic radiation is neutral. That means it doesn't has any charge. Just when, can you give me more examples of electromagnetic radiation? For example, gamma rays, electromagnetic radiation. What are other electromagnetic radiations? Can you give me a few more examples?
I didn't get you.
I'm just saying that gamma ray, I told that it is an electromagnetic radiation. Is there only gamma ray as electromagnetic radiation, or we are having any more electromagnetic radiation? We are having various other electromagnetic radiations. Can you name few of them? For example, what is visible light? That is also your electromagnetic radiation, isn't it?
Filament from the bulb.
Similarly, we are having the radio waves. What are those? Radio waves are also the electromagnetic radiations. We are having the microwaves. What are those? They are also the electromagnetic radiations. We are having the X-rays. What are those? They are also the electromagnetic radiations. So that is why you will remember that all these are your electromagnetic radiation. Gamma ray is also your electromagnetic radiation. Is it now clear? So it is neutral. That is why it will not get deflected either towards the positive plate nor towards the negative. Got it? Have you got what is gamma ray?
Yes, sir.
Yes, exactly. So then let's move ahead. So we have completed this discovery of radioactivity. Now let's see also, you will remember that there was one scientist known as William Roentgen. William Roentgen. So what he discovered? He discovered X-rays. Discovered X-rays. See, actually what he did, William Roentgen, we have already discussed the discharge tube experiment, isn't it? So what Roentgen he did, he actually, so here it was the cathode, you are right. I hope you remember in the discharge tube what we are having, we were just having the cathode and we were having the anode, right? Now what William Roentgen did here, he just take this cathode as very heavy metal like tungsten. Let's take it as tungsten. Tungsten is a very hard metal, it is heavy. So when cathode rays fall on this, when electrons, I may say just that when electrons fall on this cathode, what happens? Some rays are just getting emitted from this and they just go out of this discharge tube. That means they can just pass through this glass tube. And how it was actually observed? Here it was placed the fluorescent material, that is your zinc sulfide screen. And what was observed? It was observed that it starts glowing, right? It causes the fluorescence here. Bright spots are formed here. So these are your bright spots. So it indicates that there are some rays which are just coming out of this discharge tube, and these rays were known as William Roentgen, he was not knowing that what type of rays these are actually. So he named them as X-rays. Just as what we say in mathematics, when we don't know any value, we say let it be X, right? So William Roentgen, he told that let it be X. So at that time, they were known as X-ray, and now from till now their name has not been changed yet, so they are still known as X-rays. So they are actually, they are also your electromagnetic radiation which are having very high energy. So I will write that the X-rays are high energetic electromagnetic radiations. Got it? Electromagnetic radiation. Exactly. So you will remember that just as your gamma rays are electromagnetic radiations, X-rays are also your electromagnetic radiations, and they have high energy. So just that is why these X-rays, they are used to study the structure of bones, right? They are used to study the structure of any solid object, any solid material, because they can actually pass through the interior of any bone, any solid material. So that's why you can see here that in this discharge tube, these X-rays, they pass out of this discharge tube. That means they can pass through the glass. They are having very high penetration power. They can easily pass through this glass tube, and when they strike with the zinc sulfide screen, which was outside this discharge tube, it started glowing, which clearly indicates that these rays can pass out of the discharge tube through the glass tube. So they were at that time known as X-rays because William Roentgen didn't know what type of rays Actually, they are. So he told them as X-rays, and still now we are just calling them as X-rays. Their name has not been changed yet. Got it? So this was the discovery of X-rays. Is it clear? Have you written down this?
Yes, sir.
Okay. Then now if I will just compare, we are having alpha rays, that means alpha rays, beta rays, and the gamma rays. If I will just ask you that which of these rays will have very high penetration power, if I have just to write the order of penetration, do you know what is penetration power here? That means which ray can easily pass through any metal foil. Let's say we are just taking the aluminum foil, so which ray can easily pass through that?
Gamma rays.
Order of, yes, exactly, gamma rays are having very high energy, so they can easily pass through any material, so that's why they have very high penetration power. So you will remember that gamma rays have very high penetration power. Then it is the beta rays, that is the beta particles, and then it is the alpha. Got it? This is very important, the order of penetration power. So actually here you will note down that these gamma rays, they are having very high energy, they are highly energetic, they are more energetic than X-rays. So that is why they can easily pass through any substance. So that is why they are having very high penetration power as compared to beta rays, as compared to the gamma rays. For example, if you have to compare, you will just write that these beta rays, they are having 100 times more penetration power than alpha rays. Got it? If you will just compare. And similarly, gamma rays, they are having 1,000 times more penetration power than alpha rays. So you will remember this. This is very important here. The penetration power. I'm again repeating that in case of alpha rays, the penetration power is very least, it is very less. Beta rays are having more penetration power than alpha rays, and a very high penetration power it is possessed by gamma rays. And if you will just compare, beta rays, they are having 100 times more penetration power than alpha rays, and gamma rays are having 1,000 times more penetration power than alpha rays. So have you got it? Any doubt here?
No, sir.
Any question? Okay. So then let's recap each and everything which we have studied until yet. So first of all, I told that discovery of proton. I told that in case of discharge tube, if we are just taking a perforated cathode, perforated means which are having what? Which are having small holes in it, right? Isn't it? If there are small holes or small pores inside the cathode, then what happens? These anode rays, they can easily travel through these canals or the pores or the holes, and they can strike the fluorescent material, that is your zinc sulfide, and it starts glowing. So which clearly indicates that along with the cathode rays, some particles are just moving in the opposite direction from anode, and they are moving towards the cathode. And they were known as anode rays or positive rays. Their property was actually studied by Goldstein. So what he got that these anode rays, just like the cathode rays, they travel in the straight path, isn't it? They travel in a straight path, and then then he also concluded that these anode rays, they are made up of material particles, isn't it? And then he also observed that these anode rays, they just get deflected towards the negative plate, which indicates that they are itself made up of positively charged particles, which are actually your cations. But when you take the hydrogen gas, then at that time we call it as proton. H positive is the smallest cation, which is actually having proton in it, only single proton. So that's why it is your proton. So proton, its mass, we have told that it's 1.6723 into 10 raised to power minus 27 kg. And then I have told the charge of the proton, it is plus 1.602 into 10 raised to power minus 19 coulomb. And after that, I told that these anode rays, they do not, it matters when we take the different gases. That means their charge upon mass ratio, it is different for different gases, isn't it? And then I told that these anode rays, they have different mass and similarly different charge. But when we take only the hydrogen gas, at that time, E upon M ratio will be different for as compared to with other gases. After that, I told that the relative and the actual charge and mass of these protons. So in case of proton, the actual mass, I have told that 1.67 into 10 raised to power minus 27 kg, but its relative mass is taken as 1 unit mass, right? Similarly, I told the actual charge is plus 1.602 into 10 raised to power minus 19 coulomb. That is actually taken as 1 unit positive charge, right? So after that, I told the discovery of radioactivity. So in this, I told that it was which scientist? Can you name the scientist? Stesh, can you name the scientist who discovered this radioactivity?
Sir, he was Henry Becquerel.
Yeah, it was Henry Becquerel. It was Henry Becquerel, right?
Yes, sir.
Exactly. So what he did, he just take the radioactive material like uranium. I told that all those elements which are after uranium is having atomic number 92. So after that,
92.
any element is your radioactive element. So what is a radioactive element? It is that element whose nucleus is unstable. That means
Unstable
which is
units.
high. Exactly, it will emit various radiations. So this spontaneous emission of various radiations, it is known as radioactivity, right?
Yes, sir.
So he observed that 3 types of radiations are emitted by this uranium, by this radium or plutonium, any radioactive element. One is your alpha rays,
Alpha
beta ray.
rays.
Exactly. So alpha rays, they contain the alpha particle, and I told that alpha particle is your positively charged
Helium.
particle. Yeah, exactly. It is your helium nucleus. That is He2 positive. So this is very important here, that sometimes it is objective is asked that which is alpha particle. So options are He positive, He2 positive, and He2. So which is correct?
He positive.
No, it is He2 positive is correct, right? I told it is
But-
having 2 units positive charge.
Okay,
Correct?
sir.
Yeah, it is not He positive. Alpha particle is He2 positive. Got it? Yeah. Okay, then I told beta particles. So alpha particles having 2 unit positive charge and 4 unit of mass. And then I told about the beta particles. Beta particles are just the fast moving electrons. They are just like the electrons. So they are having same E upon M ratio as that of electron. And after that, I told gamma rays, they are your neutral electromagnetic radiations. They are just made up of electric and magnetic field and magnetic field lines. So this was the discovery of radioactivity. After that, I told the how X-rays got discovered. So it was the SAM discharge tube experiment, and it was the William Roentgen. What he did? Yeah, exactly. He just struck the electrons, that is the cathode rays, on a heavy metal like tungsten. So what you observe, yeah, exactly. There are some rays coming which are moving out of the discharge tube. They are moving out of the discharge tube. That means they are having very high penetration power. They are highly energetic, and they can be seen with the help of zinc sulfide material, which actually produces bright spots outside the cathode tube, discharge tube. So they were known as at that time X-rays, and still until now their name has not been changed. They are still known as X-rays, and we use these X-rays in the medical field. Just whenever there is any whenever there is bone fracture, what we do the X-ray, isn't it? So that means X-rays, they can pass through the bones, so we can take the picture of that whether bone is fractured or not. So they are used there, so they have applications. So this was the discovery of proton, and now we have got what is actually alpha particle. In the next class, we will study the discovery of neutron, and then we will study various phenomena. I hope you will just go through the text and you will just study these. They are actually your isotopes, then isobars, then isotones, then isodiaphers, then isoelectronic species, then isomers. So all these topics we will study in the next class. Wish you all the very best. Have a nice day ahead.
Thank you, sir.
Most welcome.
In fact, I wanted to ask questions. Ready, yeah? So radioactivity. What is radioactivity?